Hi everyone, I'm going to solve this differential equation question for you guys today. As you can see, it looks complicated, right? Yep, well it is. It's complicated, and that's where I come into the scene to help you guys solve this question. And I'm sorry if you guys hear noises from the background. Like every time I decide to make a video, someone is talking and making noise. It's like that. I don't know why. I'll get that clarified soon. I'm working on this thing where like you could cancel out background noise. So just give me some time on that. So for now, I'm re- I re- I'm really sorry if you guys get disturbed by any background noises. So yeah, let's get on with this question. So you have y squared into the second derivative plus 2y squared into the first derivative plus 2y into the first derivative squared minus 5y cubed equals 8e to the power minus x. Okay. And they've given us a substitution of v equals y to the power 3. Okay. So what we do is, let's differentiate y to the power 3. So we have dv over dy equals 3y squared, right? But in our question, we have dy over dx and the second derivative of dy over dx. So we'll have to find dy over dx, right? So what would dy over dx be? So dy over dx equals to dy over dv into dv over dx, right? This is the chain rule. So dy over dx equals to dy over dv. But we have dv over dy. So it's going to be the reciprocal, right? 1 over 3y squared into dv over dx. Now we found a substitution for the first derivative, right? So instead of dy over dx, we can straight away put in this, right? So now let's find a substitution for the second derivative, I'm sorry. So the second derivative equals to 1 over 3y squared into, so the derivation of dy over dx, since dy over dx is in terms of x, when you differentiate dy over dx in terms of x, you get the second derivative of dy over dv over dx, right? Plus, it's the chain rule, dv over dx into, guys, there's a bit of background noise over here, I'm really sorry about that. So dv over dx into 1 over 3y squared. So what's the differentiation of 1 over 3y squared? It's 1 over 3 into y squared comes up, right? So the differentiation of y to the power minus 2 is minus 2 into y to the power minus 3. But don't forget, you have to multiply this. Since you're differentiating y in terms of x, so what's the differentiation of y in terms of x? It's dy over dx, right? Don't forget that. Because you have y over v. It's not x. If it was x, it's just that. Because we are differentiating in terms of x. But here we have y. So when you differentiate y in terms of x, you have to write dy over dx. Don't forget that. Okay? So your second derivative is 1 over 3y squared into the second derivative of dv over dx plus, sorry, minus, since we have minus over there. So it's 2 over 3y cubed into dv over dx into dy over dx. Okay, so this is the substitution for your second derivative. Let me write with another color, or else might be confusing when you have too many variables, right? So what I'm gonna do is, so I write the question again. So this is further max, if you guys are wondering. This is Cambridge further max. So yeah, I guess students who are doing mathematics for their higher studies, this might be helpful for you guys. So let's say you're doing engineering. So if you're doing engineering, This will be helpful for you guys too. So yeah. So this was the question, right? Sorry, it's 8 e to the power minus x. Yup. So now we put the substitutions. So y squared into... Now we can put in this instead of the second derivative of dy or dx. So 1 over 3y squared into the second derivative of dv over dx minus 2 over 3y cubed into dv over dx into... So dy over dx. So instead of dy over dx, we can put in this, right? Which is basically that. So we can write 1 over 3y squared into dv over dx, right? Plus 2y squared into dy over dx is same thing, 1 over 3y squared into dv over dx plus 2y into dy over dx squared. So that's 1 over 3y squared into dv over dx squared, right? Minus 5y to the power 3 equals 8 e to the power minus x. Now let's simplify. It's simplification, right? So 1 over 3 into the second derivative of dv over dx minus y squared into 2, 9, y to the power 5. Look carefully at what I'm writing, alright? Because you can see 3y cubed into 3y squared gives you 9y to the power 5, right? Into dv over dx squared, right? And now I'm focusing on this. Plus 2 over 3 dv over dx. Let me just, yeah, I'll just write with blue, and the next step I'll write with red. Plus 2y into 1 over, now I'm focusing on this, 1 over 9 to the power 9y to the power 4 dy over dx squared minus 5y to the power 3 equals 8 to the power minus 6, right? I'll change colors now, because this might, if you just, let's say you don't watch this video from the start and you just go right to the center, it's like you dropped a guy to, like, let's say you're watching film or something halfway through. It's it's like a chaotic scene where you have no clue of what's going on, right? So you have to watch the video from the beginning to know what's happening right now, right? So we have 1 over 3 to the second derivative of dv over dx minus 2 over 9 to the power 9 into y to the power 3 into dv over dx squared plus 2 over 3 dv over dx plus 2 over 9 to the power 9 into y to the power 3 into dv over dx squared minus 5y to the power 3 equals 8 e to the power minus 6. Look at the beauty of mathematics. That's why I have it in my description. Look at this. These two cancel off. See, in your question, this makes it so complicated, but the substitution just pulls it off, right? So you don't have to worry about it. So now we have 1 over 3 into the second derivative of dy over dx plus 2 over 3 into dv over dx. I'm sorry, did I say dy over dx? It's dv over dx, alright? I might be jumbling y and v, so that you guys can understand what's going on, right? Yeah. So now let's multiply everything with 3. So now you have 2 dv over dx minus 15 y to the power 3 equals 24 e to the power minus x, right? So now we had the substitution of v equals y to the power 3, right? So now we can put in the second derivative plus 2 into the first derivative minus 15v equals 24 e to the power minus x. Now all you have to do is just solve this, which is very easy. I'll show you guys. So how do you solve this? You see the second derivative, first derivative, and minus 15v, right? So that's actually a quadratic equation. If you guys don't know about this, so these are the basics of differential equations. So I'm not going to go through the basics, but if you guys need help with that, please drop a comment. I'll help you guys with that. So basically solving this is, you can write lambda squared plus 2 lambda minus 15 equals 0. You have to solve this quadratic equation to find lambda. I'll show you guys where this is going. So lambda, so what factors of minus 15 gives you 2? So it's lambda squared plus 5 lambda minus 3 lambda minus 15, right? So lambda into lambda plus 5 minus 3 into lambda plus 5, right? Lambda equals, lambda plus 5 into lambda minus 3 equals 0, right? So you have lambda equals minus 5 and lambda equals 3. So when you have this case, you should know your solution is going to be a e to the power minus lambda plus b e to the power lambda plus y. Alright, it says capital Y, and alright, plus y. Plus y is going to be related to that, to the 24 e to the power minus x. Okay? I'm sorry, it should be lambda. In this case, it's x, right? So it's x. Yeah, I forgot putting that. So then your solution is going to look like this: a e to the power minus 5x plus b e to the power 3x plus y. We won't be able to find the values of a and b since they haven't given us when y equals 0 or something, x equals that, or when dy over dx equals something, you'll get something else. They haven't given us coordinates, right? So we don't have those coordinates. So we can't find a and b. You can just give your general solution. So now we'll have to focus on y. So we have 24 e to the power minus x, right? So what do you do with that? So we can write y equals alpha e to the power minus x, okay? So now let's differentiate this. Dy over dx. I'm really sorry. This has to be v, not y. I'll tell you why, because I'll write this as capital V and this as simple V. It just came into my mind now, because the second derivative, the first derivative, they're all in terms of v and x, right? So we don't have y in them, so it's only v and x. So this has to be v. I'm really sorry about it. So this is v equals 24 e to the power minus x. The question's a bit big, you know, it gets you crazy sometimes. So yeah, you might lose focus sometimes, but then when you recheck, you see your mistake, right? So that's how it is when you do math. So let's differentiate this. So it's minus alpha e to the power minus x. And let's find the second derivative. It's plus alpha e to the power minus x, right? So now we can substitute these back into our differential equation. So we have alpha e to the power minus x plus 2 into minus alpha e to the power minus x minus 15 into v, which is alpha e to the power minus x, equals 24 e to the power minus x. So you can cancel off e to the power minus x. So now we have alpha minus 2 alpha minus 15 alpha equals 24, right? I think I am correct. Yep. So this is minus alpha. So minus alpha minus 15 alpha is minus 16 alpha, right? So alpha equals 24 over 16, minus 24 over 16, which is So what are the factors? 8, right? So 3 over 2. So you can write v, simple v equals minus 3 over 2 e to the power minus 6. So your final solution is v equals e to the power minus 5x plus b e to the power 3x minus 3 over 2 e to the power minus 6. There's one more thing you have to do. So it's v, right? But we had the substitution v equals y to the power 3, right? So you can put that back in. Y to the power 3 equals e minus 5x plus be 3x minus 3 over 2 e to the power minus 6. This is your final answer. Whew, that was a big question, right? That's everything for this question. So if you guys have any doubts, please drop a comment. I'll help you guys out. And yep, that's everything for this question. If you guys like my video, leave a like and subscribe. Have a great day. Thank you so much.